Alrighty, we are going to be talking about probability distribution functions. I'm going to be running through a couple of examples. If you haven't already, go to the link that is in the description box for someone who does a really good job at explaining what they are. So the first problem we're going to do is 100 chickens were randomly selected from a large poultry farm. 18 were determined to be infected with salmonella. Assuming the sensitivity and specificity of the diagnostic method are both 100%, what would be the true prevalence of salmonella on the farm? Cool. So when we're looking at the different distribution functions, we've got to figure out which one this matches. So have a little think and pause the video if you want to have a think. But for those who didn't, or now that you're back, we would use a beta distribution function for this one. Because remember, a beta distribution function estimates the probability of an occurrence of a specific event from an observed number of events or trials R in a specific number of trials. So an easy way to remember it might be that it calculates the true prevalence of something. So you beta get the right prevalence. All right, so let's have a look at the numbers. We've got our so for beta, we've got alpha and beta, aka alpha 2. So alpha equals r plus 1, and beta equals n minus r plus 1. Now, what are these individual numbers? So r is the number of observed events or trials. N is the specific number of events. Sweet. So that's kind of all we need. So how many observed events did we see? 18. How many number of events did we try, or how many different how many trials did we have? 100. That's right. So do we need to put in the probability? Probability. No, because that's what we'll try and work out, because the probability is essentially like what is the true prevalence. This is what we're trying to figure out. So with distribution functions, it's kind of a brute force / trial and error sort of thing. So we actually make tables for this. So X is the prevalence, and then this column is the probability of that being the case, the distribution function of beta. So if we wanted a ballpark thing, where is the prevalence going to be around? It's probably going to be around 18%, right? Because 18 out of 100 is like 18. But we want to know the distribution of this. So we might start with 0, might go to 0.05, and you can extend it using that little box on the bottom. So let's go up to 0.3, and then from here on, just for the sake of the argument, let's do that. And then we don't go above 1. Why? Because the prevalence doesn't get above 100%. Make sense? Cool. So now we calculate the beta. So you need, I don't know if you need a specific thing for this one. No, you don't need a specific program for this one. Excel has this already. So you just go beta distribution, tink. Now, what is X? Now, X is our prevalence, but this is what we're going to try and figure out. So that's why we use these ones here. So just click that button. So what's the alpha? The alpha would be this. To calculate it, so R, which is 18 minus 1, and plus 1, 11. All right, so alpha, and then what's beta, aka alpha 2, and that's n minus r plus 1. So n is 100 minus 18 plus 1. Close. And then do we want it to show the probability for each one of these individually, or do we want it to show the cumulative effect, so to that prevalence and below? And in this case, we do want to see the cumulative probability one, so you just hit tab, close brackets, enter, and it's going to be 0. So let's just extend that out, because remember, this will incorporate the one that's directly across. I think. Cool, so we've got some numbers here. What does this all mean? So the best thing to do now is graph it. So let's go insert with a scatter graph. That's often quite helpful. So this is the distribution of risk. So what this means, we can even just pull these numbers down a bit because we don't need so many. Let's just go to 0.5. Okay. So just zoom out. Cool. So in this problem, the probability that or the chance that the prevalence is 15% or less is about 17%. Does that make sense? So there is, for this one, there is a 99% chance that the prevalence is going to be 30% or less. And this is what this is showing. So I'll add some axes. So this is prevalence of salmonella, and this one is ability. Now remember, so this, we actually don't need to go above 1 here, so we can just make one a bit smaller, and we also don't need to go below 0 because we're only going 0 to 1. And the chart title might be, let's get that one. So distribution function of salmonella in chickens in a large poultry farm. And remember the conventions by which we name it. So we say beta, and then we would put in the alpha and the beta here. So we would put 18 plus 1, 100 minus 18 plus 1. Cool. So that is how you use the beta distribution function in Excel. So beta, you're looking for the true prevalence of something. Yeah, any questions, just post them in the comments. I'll be doing some other videos